Hi class, this is going to be a really short lesson. We're just going to touch very lightly on 8.4 scientific notation because you've seen it before. I'm just going to go over, I'll take 5 minutes tops this lesson. Okay, so here are the rules. A number is written in scientific notation when it is in the form of C means any number, times 10, N means any power, okay? Where C, the number, is greater than or equal to 1 and less than 10. Okay, so you can see these inequalities. And N is an integer. Alright, so let's go ahead and look. This would be the number 2 million or 5 thousandths. Standard form, we write it out the long way. That's a way to think. It's sometimes called expanded form. So there's 2 million. And then taking it into scientific notation because it's a bigger number, so you expect the exponent to be positive. That's one of the ways that you can tell. If it's a really small number, you're going to have negative exponent. If it's a large number, it will be positive. So you can see that it has 6 zeros, right? So you would write it 2 times 10 to the power of 6. So that's what I was saying. Scientists use this a lot, so they don't have to write all these zeros when they're dealing with planets or really small bacteria or things like that. So they're going to go ahead and write it in scientific notation. Here, 5 thousandths, that's it being spelled out. Here it is in standard form, 0.005. And then we're going to write this in scientific notation. Thousandths is 3 place, but it's thousandths, so it is 3 places back. 5 times 10 to the negative 3. So here is originally where the decimal would be, 1, 2, 3. Okay, so we're just going to do a few of these. You have already seen this before, so 42,590,000 equals, we're going to change this from standard form to scientific notation. So here is the understood decimal. And remember, the rule says it has to be larger than 1 and less than 10. So that tells you where the decimal goes. So if I'm looking here, I've got all these numbers, 4259, before I get zeros. So it obviously has to be between 4 and 2. So I'm going to go ahead and do that. I know where the decimal is. Any numbers that are not 0, you write out. Okay, so I know I'm going to write that times 10 and it's positive. So this is how I can tell. So think about the decimal here. 1, 2, 3, 4, 5, 6, 7. So 4.259 times 10 to the 7th. So you always have to write any number that's not 0 to a base of 10 out fully. And then knowing where the decimal is, just remember it has to be greater than 1, less than 10. So 9.9 would work. As soon as it reaches 10, it's too large. Alright, so here's another one, a negative one. So standard form 0.000, there's 4 zeros, 574. Okay, so we know the decimal's right here, so it's really small, and it has to go between 5.74. So if I put it here, it'd be 57. Here it's going to be 5.74. So that's how you can tell. All right. So it would go right here. If I put it here, it's 57. That's too big. 5.7 is greater than 1 and less than 10. And then how many decimal places have you moved it? 1, 2, 3, 4, 5. So to the negative 5 because it's a very small number. All right. So this is stuff that you've seen. We're not going to dwell on this really long. Excuse me. We are now going to write it from scientific notation to standard form. So here's scientific notation. So we're going to go ahead and write it in standard form. So if I did, I'm just going to go ahead and write this out. And I know it's got 6 zeros, so from here, 1, 2, 3, it's got 4. That means I have to add 2 more, 5, 6. That's it. As long as you can count, you can work this out. And then you always go back by 3, so that's 2 million. All right, so you can see that this is standard form. This is scientific notation. Same here, let's do a negative. 1.685 times 10 to the negative 4. So I know the decimals here, so I've got to go back. So I'm going to write 3 zeros and then just go ahead and count. All right, so I know originally it was here, 1, 2, 3, 4. So I can put my decimal and add another 0. So that's what it would be like changing it to standard form. So you had 2 from scientific notation to standard form, and then you had 2 in standard form that you went ahead and changed to scientific notation. Just a couple more things and we are done. Like I said, this is a super quick, easy lesson. Okay, so compute with numbers in scientific notation. So here's sometimes where you're going to have to multiply. 8.5 times 10 to the second power multiplied by 1.7 times 10 to the sixth power. All right, so you're going to multiply 8.5 times 1.7. Okay, those are just regular numbers, and then we know that we add when we multiply bases times 10. 2 plus 6 is 8 for right now. So on your calculator, you're going to take 8.5 and you can multiply it by 1.7. So when you do that, you get 14 and 45 hundredths, if we set it out, times 10 to the 8 right now. So that looks good. You're showing all your steps, but the problem is that this goes, it's supposed to be here. So we're going to move it and make it a larger number. So now it's going to be 1.445. So when I do that, it's going to add another 1. So it becomes 10 to the 9th. All right? So think about it as moving and making it a larger number. So it's now 1.445 times 10 to the 9th. So you have to remember to do that. It has to be in the correct decimal place. Greater than 1, less than 10. So 14.45 isn't right. We have to move it over. And there you go. Okay, here's another one real quick. 1.5 times 10 to the negative 3 raised to the second power. Okay, so remember, this is a power to a power, this is a base. So say 1.5 and we square that. We do that to that. Times 10. Negative 3 times 2 is negative 6. Then 1.5 squared, you put that in your calculator and you're going to get 2.25 times 10 to the negative 6. And that's good. Unless they tell you to write it in standard form, then you are done. So you can see it's fairly easy to do this. The last one I'm going to teach you, you've seen a multiplying. Now we're going to do a division. And I'm going through this fairly quickly because you have seen exponents before. This is just going to be a very quick lesson and just a little bit of homework on this. Okay, so division. 1.2 times 10 to the 4th divided by 1.6, 1 6/10 times 10 to the negative 3. Okay, so division works just like you would think it would work. You're going to divide 1.6 into 1.2. So I'm going to go ahead and show how you do that. Times, and then you've got 10 to the 4th, and these are same bases, and negative 3. Okay, so when I divide 1.6 into 1.2, You do that on your calculator, you're going to get 0.75 times 10. Remember here, we minus a -3. Remember, you're subtracting a -3, which is going to make it now positive, right? Okay. So you can see everything looks good up to here, but this is not in the right decimal place. So we're going to go ahead and we're going to move it here. So when we do that, we subtract 1. 7.5 times 10. And if we subtract 1 from 7, then we end up with 6. Okay? So the other way here it moves, and we subtract 1. When we're multiplying, we added 1. So just remember that, and that's it. Bottom line. Sometimes they ask you to order numbers, and when you do that, put them all in bases of 10s, and you'll be able to see how to order that. But that's it for this lesson.